Right. We were discussing about Java last day, and actually we learned that we need to download JDK, that is a Java development kit, right? So then then JRE, Java runtime environment, will automatically come, right? What you need to do is you have to go to the Oracle site and download JDK. So that's JDK. Okay, here. I think I need to download the Windows installation. Okay, after downloading Java development kit, JRE, Java runtime environment, will be automatically present, and we learn how to write our first program also. So to do that, let me open Notepad again, just to remind you what we have done. And so I hope that you can remember the class concept that we learned. Class is a blueprint or template for a set of similar type of objects, and object is an instance of a class. We couldn't write that last day, so shall we write that very quickly? The heading is OOP, object oriented programming. Under that we learn the concepts, terms. So one term is a class. What is a class? Class is a blueprint or a template for a set of similar types of objects. Actually, you don't have something called, actually you cannot see something called class. It's not real world, it is a template, blueprint, just a template or blueprint. In real world, you will not be able to see that, but it exists. For an example, student. Student is a class, but that is a concept. Student has student name, student ID, student first name, address, gender, date of birth, last name, all these things are there, email, all these things are there. But the thing is, if you ask what is the name of the student, then you have to ask which student, because even though this is there, we are not referring to an actual student, right? So a class has attributes or features. You can say examples. What are the attributes? A student class has student ID, student ID, student name, age, gender, date of birth, email. It also has behaviors or methods or functions. Example, what are the behaviors or functions? You can say register. So normally you can say eat, sleep, drink. Those are also functions. Student can eat, student can drink, student can sleep, student can walk, student can talk. But we can't put that into a system, no. Even though a student can do that, we cannot put those things into a system. And we cannot automate eating, drinking, sleeping. We can't automate those things. So eat, sleep, drink also functions. But the thing is, we can't systemize that. We can't make a system using that. But register, we can add it to a system. Then enroll for a course, you can add it to a system. We are normally using brackets in front of this method to show that. Register, enroll, activate, and you can say deactivate, So these are implementable functions: register, enroll, activate, deactivate. Then what? Present, absent, mark attendance. So these are functions, behaviors. Then what is object? Right? That is a real life representation. It is a real life representation, or we can call an instance of a class. Example, as an example, you can say student Minaga. Really, you can see student Minaga, and student Minaga has a student ID, a student name, age, gender, date of birth, male, and he can register, enroll, activate, deactivate, mark attendance, space. So actually the student can do that. So that is real student. Okay, so we need to learn these terminologies. And meanwhile, I think my installer is downloaded. I can just install that. Oh, sorry, you are still writing, right? Can you see this?
Yeah, I can see it.
Meanwhile, I'll go to the installation wizard. Make it the corner. Once installed, I said like you can test this. If you put Java, that is the interpreter. Oh, it's not working. Java C. Doesn't matter. I think I have to make the path because the installation location still not detected. So easiest way is I can manually browse for the installation location. This is happening in Windows, but in Linux, this was not happen. Linux has automatically taken that. But in Windows, I think we have to move to the installation directory, program files, Java, JDK, bin. Inside that, Java C is there. Here, Java EXE and Java C EXE, both are there. So what you need to do is you have to copy this, copy the installation path, copy this path, and so as a one-time work, you can say path equal, then you can paste this, but you need to do this every time. When you're setting the path, you need to do this, but that is headache, no? Therefore, you can go to the you can go to my computer or this PC, then go to the properties. There you can see advanced system settings. There you can see under the advanced environmental variables, there you can see there's a variable called path. You can edit it. If this is not there, right, you have to add a variable called path. But since there is a variable called path, you can edit it, and you can edit this also. Put a semicolon and put that path that we have just copied. Now there are two paths. Right, the first path is that. Okay, this is second path. Can I add this to a new line? I'm just checking. If I can add this to a new line, it's better, right? Cut it. Let's try to add it to a new line. Edit text. Oh, right. Okay, let's add it here. Okay. Right. Click OK. Okay. Let's try to put the command again. Now Java C. Oh, I'll close it again and take. Okay, done. Now the command is working. Fine. Have you finished writing this?
Yeah, I have.
Okay. So let's go to Notepad again. Now this is our note, and I need. So let's save this. Java note. The next important thing is the type of variables that we just studied, like integer part we just studied, but there are more variables. So integer, float, double, char, boolean. Actually, there are 8 types: int, short, byte, long, float, double, char, and boolean, right? A lot of variable types are there. But you know about integer and you know about float because we have learned that, and string we have learned that in Python, and Boolean, that is logic variable. Yes, we have learned those variables in Python, but here there are more types. We call Java primitive data types, right? Primitive data types, and there are 8. Okay, I think this is clear. Primitive data type, you have Boolean, which is logic, character, char, integer. There are 4 types. Byte means small integers with 8-bit. Short means long integers. Not long actually, short means like 32-bit, 16-bit integers. Integer means 32-bit. Then long means, have you turned on the microphone? I can hear big noise.
Oh, sorry.
Okay, if you have question, you can ask, right? It doesn't matter. If you have question, you can ask. Okay, right, then numeric, so this can be character, byte, short, int, long, and then it can be a floating point. These numbers can be like full numbers or the fractionals like a float and double. So these are having sizes, and these are having sizes. This is also another example explaining the primitive and non-primitive. Let's use this. I think it's good. Yeah. So let's use this chart, and I cannot paste this in Notepad, unfortunately. Right, let's draw it somewhere. Sorry. Let's draw it somewhere. So can you type this heading? Data types in Java. Data types in Java. Then please draw this. Right. Boolean. So let's explore these data types further and how these are like presented. I'll let me explain that to you first. One thing is here, Boolean is basically 1-bit variables, 1 or 0 is recorded, that is true or false. So that is same as what we have learned in Python. And then this 2's complement integer is something that 2's complement is a number representation where the number is represented using given number of bits. Let me show something to you. 2's complement actually no need to learn, but just to get an idea. So what is this 2's complement? If a positive number 10 is like positive number, let's say 12 is a positive number. So what is the binary value of 12? Binary value of 12, you know how to convert that. You have to divide by 2 and write the remainder. Can you tell me the binary value of 12?
0.
Sorry. Binary value of 12.
Oh,
You can calculate. 12, what you need to do?
need to
You have
divide
to
it by
divide by
2
2,
and get the
then write the
remainder.
remainder. 6, remainder 0. Divide by 2 again, then 3, remainder 0. Divide by 2 again, then it is 1, remainder 0. When all are ones and zeros, you can take from bottom to top. So the value is, what's the value? Oh, sorry, one, last one is wrong. Last one is wrong. 1 remainder 1, right? 3 divided by 2 is 1, remainder 1. So the value is 1100. So can you remember this?
Yeah, I can.
Then
Oh,
actually,
yeah, no, I remember.
Sorry?
Yeah.
Right, okay. Then you have to write this is in 8 bits. 1, 2, 3, 4. Then 5, 6, 7, 8. Okay. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. This is how you are writing 2's complement positive number. 2's complement positive 12. So if you want to write negative 12, right, there's another way. Negative 12 is written by reversing this. Reversing means all zeros need to be inverted to 1. All ones will be inverted to 0. All zeros inverted to 1. Then you need to add 1 to this. And then this number will become 1, 1, 1, 1, 0, 1, 0, 0. Because like this 1, 1 is 3. 3 plus 1 is 4. 3 plus 1 is 4. 4 is 100. And this is 2's complement negative 12. So actually 2's complement is represent a method of representing right, method of representing these integers, positives and negatives. Here 8-bit means we can go maximum. So how the range comes? Let's see how the range comes. We need to learn that as well. No, the range comes like this. Maximum positive is this 0. That is our sign, right? The first bit is the sign 1, 1, 1, 1, 1, 1, 1. So what is the value? This is, you know how to calculate 1s, 2s, 4s, 8s, 16s, 32s, 64s. I think you can remember the abacus. So here this is also having a kind of abacus for 2's complement numbers, sorry, binary numbers. If you use such abacus in decimal, you know, ones, tens, hundreds, thousands, that is how it moves, no? Ones, tens, hundreds, thousands, 10,000s, 100,000s. That is how it moves. But for binaries, it moves like this. For binaries, you can say the numbers moving like this, right? Numbers moving like this. That is for the binaries. Okay, how the numbers move? Okay, here you have numbers like this. Ones, twos, then fours. If you don't know, please write down somewhere how to convert these binary numbers. I said this previous time also. You need to learn about this number system. Otherwise, this will be a bit confusing when you are learning programming. You need to know how this works in 64s and then 128s. This is 8 bits now, but the this 128, this bit is never occupied because This bit is in this system, the first bit is occupied for sign. If this bit is 0, then it is positive. If this bit is 1, that is negative, right? In this negative numbers, let me write here. Negative numbers will be represent sign bit 1. So for the positive numbers, sign bit is 0. Sign bit is 0 for the positive numbers. Negative numbers, sign bit is 1. Positive numbers, sign bit is 0. Here sign bit 0 means it is positive. Now you have to add, like, there is 1 from each. 1 from each. 1 from each means there's 1 from 1, 1 from 2s, 1 from 4s, 1 from 8s, 1 from 16s, 1 from 32s, 1 from 64s. So what is the number? You need to add them together. 64 plus 32 is 96, plus 16 is 106, 112, plus 8 is 120, plus 4 is 124, plus 2 is 126, plus 1 is 127. So this is how the maximum positive number comes. So the maximum positive number that you can use using 8-bit is plus 127. The maximum negative number that you can represent is this. This is the maximum because you are inverting, no? Inverting, you have to invert. Sign you cannot invert. Sign is negative. When you invert, all these things are inverted. Then you have to get that back. This number you have to invert that back. Then 127, and you have to minus 1 from that because this is after adding 1. No? 128 minus 127 minus 1. That minus 127 minus 1 is minus 128. That is how the minus 128 comes. Minus 128. So this is how the range comes. In case if you need, you can take a snapshot of this. So in case if you need, if you don't know something, please tell me, then I can explain now itself. This is explaining the range. So please write down this quickly.
All right, I got it.
Okay. Then right. The next is like after byte, there's another one. That one is this. Like, let me go to next here. Short. Short is similar, but it's having 16 bits. That is why the range is high here. Negative 32,768 to positive 32,767. The range is high because the reason is why range is high because there are 16 bits. That is the short. Int has more range. that has 32 bits. Here it has 8 bits only, 8-bit range is this, but here when you increase the number of bits, you can represent more range. More the number of bits, more range is there. Then less the number of bits, less range. More the number of bits, more range. Here long is having 64 bits. Can you see the range? It can even go up to this number. It's very, very, very heavy, large number. That is long. All are integers, all are integer numbers, but based on the size of the integer, we have to select the variable type. Right? Let me show this practically to you. And if I use something wrong, it will be prompted to me. For an example, so let's create a Java program quickly. And I'm using this notepad. I need empty notepad to write this. Is this empty? Yeah. It's not empty, but kind of. Right, okay. Let's erase this. Write in my Java program there. It's a class hello. And then, so can you remember the syntax? We learned this last day. After that, what do you need to write? Class definition after that?
Let me see.
Yes. After the class definition.
I forgot. Let me see if I can. I know I can find it.
You
Don't remember. Wait, I think got it. Is it public?
Yeah, public static
void
main
string.
yes, that is our main method. This is where the execution starts. Then I can say let's have a variable of byte variable, right? Just to show you, byte x equal 10. So it will be supported if I try byte y is equal to negative 90, still it will be supported. If I try to assign something like this, byte k is equal to 130, this should give an error because byte, the maximum range that you can go is 1 to 7. You are assigning something bigger, which will not be supported. Let me save this. I have to save as the same name as the class name. You can also try this with me. Let's save this in desktop. And I'm going to use the same name as the class name, hello. In all files, then Java, hello.java, save it, go to the command prompt, then cd, I'm moving to the desktop, Java C hello.java. Okay, can you see? This gives an incompatible types, possible lossy conversion from int to byte. Yes, here possible loss of conversion because I'm exceeding the level. But if I use short there, short is the next. What is short? Short is the next here. 716 bits. Save it. Trying to compile that. You can see it's compiling without any error. So range need to be considered. Generally, we can use integer int, but the thing is, if you are using special this less byte or short or something, then you need to consider about you need to consider about the range too, right? Then I think you are clear about this byte, short, int, and long. The next is for the fractional numbers. There are two things: float and double. Actually, this IEEE 754 format I can explain, but that will make your life like complex. So for the moment, just remember these as fractional values or the decimal points, right? If it is a float, you need to add letter F to the end here to mention that a float either capital F or simple F. And if it is a long value, you have to add capital L to the end. If it is a float value, simple F or capital F to the end, right? If it is a double value, you can either use D or skip the D and net. So these are some special things. And byte, basically byte and short, you can see examples are same. Characters, you can add give the character or character code. This is how you give character code: Unicode character code, or escape sequence. So special characters, you can escape it. New line, / escape sequences, you can write characters like this. And for double, you have D. Float, there's F. Long, there's L. Means. So let's do this practically. Then it's easy to you to remember this. And adding short, okay, char character value. I can just type single character, maybe D. It's a single character, or I can give a Unicode sequence. Can use U and use the 4-bit code. This 41 is, I think, letter A. U. Or even you can give a number. That means like for character is anyway, character is integer. So you can assign a number to, right? Character is also a number. If characters are having values, you can just say star Y is there, D, A, B. Is even you can assign a number. Character is having how many bits? 16 bits. So the range is basically, if it is 16-bit, you can go up to these numbers. 16-bit numbers, 32,000 somewhere. That is also supported. Then let's say string. The other one is double float. Float. Say you have to tell the decimal number, and if it is must. If it is long, you have to enter the number and type L letter there to show that that is a long number. Double numbers, you can just type the number, or you can just type even integer, but that will be converted as into double, and you can even type with the letter D. These are the ways of representing numbers. Let's compile, and you can see no errors, means this is working. Now after this, try to print these characters. So in order to print, you have to use system.out.println, then type the character. Keep on printing all the numbers. Try to see whether is there a difference after printing that Boolean I couldn't give. Boolean. False. Right. Other things I think I have given short. Char, Boolean, int I have not given, so int also you can be int. X is printed, then Y is printed. You can print the other characters. Sorry. Okay, try to print the other characters and see. Write this code, try to print the other characters and see. Okay, now
this meeting is being recorded.
Type class hello to or something, you can type there another new name. If you want new name, you have to change the file. Now save this as hello2.java. Where's the location? The location is inside the documents, inside the download. So where's your document? So are you inside the download? I think capital D document, right? You have to first go to the directory. Otherwise, how can it find the file? Now compiling command is Java C. Java C space, then the file name. Okay, press enter. No errors. Compile. Now Java and hello. Press enter. No, don't type Java again. That's wrong. Only hello, only the class name. Printing the values now. So other values you need to print, right? These you have to add few more statements. That is system.out.println x, y, and then k, j, w, b, all these things without print. Okay. Please update the code. That means after line number 18, other lines can be added. Okay. I think with the time we have done this. Next day, now you know about Java data type, primitive data type, but there are data types also that we need to learn next day. And operators, right? You can try the operators that we have learned in Python. It should work in Java. That means how you should try operate. Can you go to the go to the line number 18, press enter, and then in the new line number 19, right? Go to the end of line number 18, press enter. Then again type system.out.println.
Okay.
Spellings. Okay. Now write an operator. You can say x within bracket x multiplied by y. X multiplication sign asterisk y. Semicolon at the end. So likewise, try to apply the operators as a homework. Try to do this. Compile it again. Can you see? It's multiplying, right? So likewise, right. Likewise, you can try to apply other operators also. Please do this as a homework. Okay, I'll stop from here then. See you on next day. Goodbye.
Bye.